investigate what happens when you compose a combination of even and odd functions. So this is bringing in even and odd functions from the previous skill. I'm going to set this up in a little table. I'm going to do f composed with g. And I've got 4 possibilities here. The 4 possibilities are f is even, or f is odd, and g is even, and g is odd. You don't have to set it up in a table, but I'm just doing that to show this what's going on. So f of g of x. So f of g of x is equal to, well, if g of x is even, well, what we actually want to work out is f of g of minus x, don't we? Because we're trying to test for even or odd. So f of g of minus x. If, in this case, g is even, we get f of g of x, because g of minus x is equal to g of x. But f of g of x is just equal to the original function. And that means the composition is even. Similarly, f composed with g of minus x over here. Well, given that g of x is even, this is f of g of x, which is just f composed with g of x. So therefore, it's even. The idea of what f was didn't impact these ones. It didn't make a difference because the g of x already made it equal to the same thing. What about if g is odd though? F of g of minus x is going to be equal to f of, where if g is odd, then g of minus x is minus g of x. But if f is even, then this is the same as f of, well, because f is even, the minus just becomes f of g of x, which is equal to f composed with g of x. So this one is also even. And if we have f of g of minus x over here, this is f of minus g of x, because g is odd. And now because f is odd, this is minus f of g of x, which is minus f composed with g of x, which means in this case, it is odd. So 3 of the 4 cases we get an even function. The only time we get an odd function is if it is an odd composed with an odd.